Good day, everyone. Welcome to our Microeconomics Lecture. In today's lecture, we are going to study one of the most important concepts in production theory, namely the production function with two variable inputs, which is explained through the concept of isoquants. In our previous lectures, we examined production when we only one input was variable. Today, we will move to a more realistic situation where firms can change both labor and capital simultaneously. By the end of this lecture, you should be able to explain the meaning of an isoquant, identify the assumptions of isoquant analysis, interpret isoquant graphs, explain the characteristic of isoquants, understand how firms substitute one input for another while maintaining the same level of production. Let us begin. In reality, firms rarely rely on only one variable input. Instead, they usually employ several inputs at the same time. For simplicity, economists often focus on two important inputs, capital and labor. Labor includes workers and human effort. Capital includes machinery, equipment, factories, and tools. When both labor and capital can vary, different combinations of these inputs may produce exactly the same amount of output. This relationship is illustrated using isoquants. An isoquant is similar to an indifference curve in consumer theory. However, instead of representing equal satisfaction, an isoquant represents equal quantities of output. Each point on an isoquant shows one possible combination of labor and capital that produces the same level of production. Now let us understand the word isoquant. The term comes from two words. The first word is iso, meaning equal. The second word is quant, meaning quantity. Therefore, an isoquant literally means equal quantity. Suppose a factory wants to produce 100 units of a product. There may be several ways of combining labor and capital to produce those same 100 units. For example, the firm may use many workers and few machines, or many machines and fewer workers. Both combinations may produce exactly the same output. Since each combination gives the same production level, the producer is indifferent among them. The producer will then choose the combination that minimizes production cost. This makes isoquant analysis extremely useful in production planning. Let us come to the assumptions of isoquant analysis. Like every economic model, isoquant analysis is based on several assumptions. The first assumption is that production depends on only two variable inputs, labor and capital. Other factors remain constant. The second assumption is that labor and capital can substitute each other to the same extent. For example, if the firm uses fewer workers, it can compensate by using more machinery. The third assumption is that the shape of the isoquant depends on how easily labor can replace capital. If substitution is easy, the curve becomes flatter. If substitution is difficult, the curve becomes more curved. The final assumption is that technology remains constant throughout the analysis. This means production methods do not change during the period being studied. Now let us look at an example. Suppose a company wants to produce 20 units of output. There are several combinations of labor and capital that can achieve this target. For example, combination A uses 2 units of capital and 12 units of labor. Combination B uses 4 units of capital and 8 units of labor. Combination C uses 6 units of capital and 5 units of labor. Combination D uses 9 units of capital and only 3 units of labor. Notice something very important. Although the combinations are different, every one of them produces exactly 20 units of output. This demonstrates that labor and capital can substitute for one another. The producer can choose whichever combination is most economical, depending on weights and machine cost. When we plot these combinations on a graph, we place labor on the x-axis and we place machinery or capital on the y-axis. Each point represents one production combination. When we connect all these points, they form an isoquant curve. Every point on the curve produces exactly the same quantity of output. Moving along the curve, we see that labor decreases while capital increases. This is called input substitution. One factor replaces another, yet production remains unchanged. This idea is one of the foundations of the production. Before we conclude this lecture, let me briefly explain MRTS, or the margin rate of technical substitution. Margin rate of technical substitution measures how much labor can be replaced by one additional unit of capital while maintaining the same output initially. One machine may replace several workers. However, as more machines are added, each additional machine replaces fewer workers. This decreasing ability to substitute one input for another. This creates the convex shape of the isoquant. Consider a textile factory. Initially, the factory uses many workers and only a few machines. After purchasing additional sewing machines, the factory requires fewer workers. Output remains the same. However, after installing many machines, adding one extra machine contributes very little. At this stage, reducing more workers becomes difficult. This illustrates diminishing marginal rate of technical substitution. What is the importance of isoquants? Why they are important? They help managers choose the least cost combination of inputs and assist firms in deciding whether to invest in machinery or hire more workers. They improve production efficiency, they support long-run production planning, and they help economists understand how firms allocate scarce resources efficiently. I advise all students to solve the review questions and upload it to my Telegram page as soon as they finish the lecture.